In this video, we are going to talk about the IUPAC nomenclature of alkanes. Two things that you may have to always remember before assigning proper IUPAC names are as follows. Number one, how many carbon atoms are there in the parent chain and what is the root word for that. And then number two, substituents. Number one brings us to the most important rule in the IUPAC nomenclature, that is finding the long continuous carbon chain, which we will talk in a little while. Depending upon the number of carbon atoms in the parent chain, the root word changes. If you have 1 carbon atom, meth, 2 eth, 3 prop, 4 but, 5 pent, 6 hex, and then 7 hept, 8 arc, 9 non, 10 dec, 11 undec, 12 dodec. Try to remember at least the first 12 so that when you pick the parent chain, you can assign the proper root word. And the second thing is substituents. Let's say you have an alkane. Let us talk about the alkyl substituents first. If you have an alkane, remove one hydrogen atom and that becomes alkyl. For example, let's say you have methane, CH4, remove a hydrogen atom and that becomes methyl. If we have ethane, CH3, CH3, remove one hydrogen atom and that becomes ethyl. This will be attached to the main chain. Let us just assume that R is your main chain or parent chain. And then if you have propane, we can get two different substituents from this based on from where you are removing the hydrogen atom. If you remove the hydrogen atom from the terminal position, the one of the terminal CH3, then you get propyl. So this will be in bond line notation, will be like this. On the contrary, if you remove the hydrogen atom from the CH2, which is in the middle, then you get isopropyl. Now, when we go to the next chain, next series in the alkane, that is butane. Butane has two isomers, C4H10, Cn has 2n plus 2. This has two isomers. One is the normal butane that can give us two possibilities, that means two substituents. Depending upon where you are removing the hydrogen, and another isomer is 2-methyl propane. This can also give us two different substituents depending upon where you are removing the hydrogen. So, if you remove the hydrogen atom from the terminal position, you get the butyl chain. I am just writing it in bond line notation. On the contrary, if you remove the hydrogen atom from the CH2, group, then you get the secondary butyl group. It's easy to remember the secondary butyl, provided if we can recognize that on one side it will be ethyl and another side it will be methyl. So, you do not have to memorize the substituents. Whenever you get doubts, just write down the two isomers and see how you can remove the hydrogen from the isomer, like from where you are removing the hydrogen atom, and then you can easily remember it, what is what. So, in this case, if you remove the hydrogen from one of the CH3s, then what you get is isobutyl. So, that will be basically one of the CH3s, we are just removing the one hydrogen atom. On the contrary, if you remove the hydrogen atom from the CH position, then you get the tertiary butyl substituent. So, this is isobutyl, this is tertiary butyl. Keep it in mind that when we talk about alphabetical order, iso counts, whereas secondary butyl the sec does not count. Likewise, in the tertiary butyl the tet does not count. But for iso, we have to take that into account, whether it is isobutyl or isopropyl. This is something, just try to remember it. Now, you might be aware that 3 isomers are possible for C5H12, and that does not mean that we are going to get 6 different substituents. Just like in a C4H10 case, we had 2 isomers and then removed hydrogens from terminal and non-terminal positions, and we got 4 different substituents. Please do not think that we are going to get 6 different substituents from the C5H12 isomers. No, we are just going to get one substituent, that is the pentyl. In other cases, we just follow the systematic IUPAC nomenclature. In the earlier literature, we used to call this as isopentane, and this one we call as neopentane, and likewise removing the hydrogen atom from the neopentane, like one of the CH3s, neopentyl, that is discarded. So, that practice has been discontinued. So, you do not have to worry about naming that neopentyl chloride or something like that. You have to use the systematic IUPAC nomenclatures. Likewise for isopentane. It can also have substituents that are non-alkyl, like a halogen atom. It could be either fluorine or chlorine or bromine or iodine, but when it comes as a substituent, we do not use the word fluorine, chlorine, bromine, iodine, we use fluoro, chloro, bromo, iodo. Or it could also be a nitro, that is also a substituent, or it could be a nitroso, simple NO, or it could be diazo, or it could be an alkoxy, either methoxy, or ethoxy, or simply sometimes people do mention it as OET here, in this case like OME, people also do that. Okay, this is ethoxy. So, these are the substituents that are possible. Here are the 3 rules that we will be talking about it frequently. Number 1, choose the long continuous carbon chain with the most number of substituents containing a functional group. In the case of alkanes, we don't have to worry about the functional group. And then number 2, carbon atom bonded to the functional group must get the lowest number. In case if there are no functional groups are there, then the substituents must get the lowest possible number. And then after following 1 and 2, we just have to make sure that we are following the alphabetical order of substituents. For example, if an alkane contains both ethyl as well as methyl, then we have to write the ethyl first and not the methyl first. So these rules will become more clear to you when I talk about the examples. So let's go to the examples. Let's say we have a molecule like this, 1, 2, 3, 4, 5, and then a methyl group. How to give a IUPAC name for this molecule? Number it left to right first, 1, 2, 3, 4, 5. So if you number it left to right, the methyl group comes at 2 position. What would happen if you number it right to left? If you number it right to left, then it will be at 4 position, 1, 2, 3, 4, 5. We have to give lowest number for the substituent, and therefore this way of numbering that we did here is not correct. Therefore, the correct IUPAC name for this molecule is 2 and then put a hyphen methyl. We have 5 carbon atoms in the parent chain, therefore pentane. Let's look at next example. Let's say we have a molecule like this, 1, 2, 3, 4, 5, 6, 7, 8, one methyl group here, one ethyl group here. How to give a IUPAC name for this molecule? Number it first, left to right, 1, 2, 3, 4, 5, 6, 7, 8. Here the substituents are at 4 and 7 position. What would happen if we number it right to left for the same molecule? 1, 2, 3, 4, 5, 6, 7, 8. If we number it right to left, then the substituents are at 2 and 5 position. Thus, that gives the lowest numbers for the substituents, and therefore right to left numbering is correct for this structure. So at 2 position we have a methyl group, and at 5 position we have a ethyl group. So can we name it as 2 methyl 5 ethyl octane? No, that is an incorrect IUPAC name, because if we name like that, then we are not following the alphabetical order rule. Therefore, we have to name this molecule as 5 ethyl 2 methyl octane. That's the correct way of naming this molecule. At 5 position we have the ethyl, and 2 position we have the methyl. It's the alphabetical order that takes precedence over the numerical order. Let us say we have a molecule like this, 1, 2, 3, 4, 5, 6, 7, 8, 9. 4 position ethyl group, 6 position methyl group. If we go from left to right, 1, 2, 3, 4, 5, 6, 7, 8, 9. Let me just redraw it one more time. This time let's number it right to left. 1, 2, 3, 4, 5, 6, 7, 8, 9. Whether we go from left to right or right to left, the substituents are at the same position. Here also it is 4, 6, there also it is 4, 6. Here the ethyl group is at 4 position, methyl group is at 6 position. On the contrary, here the ethyl group is at 6 position, whereas the methyl group is at 4 position. So, how to choose in these kind of cases? The ethyl takes precedence as per the alphabetical order. Whichever number gives the lowest number for the ethyl group, that we have to take it into account. So, therefore, in this case this is correct, because here the ethyl group gets the lowest number. Therefore, the correct IUPAC name for this molecule is 4-ethyl (6-methyl) nonane. Let us look at one more example. Now, you might think that you have an isopropyl group here, you have a methyl group here. If you think like that, then you will be giving a wrong IUPAC name. Remember, we have to choose the long continuous carbon chain that has the most number of substituents. So, if you start numbering from here, so let me just redraw this structure. 1, 2, 3, 4, 5, 6. If you choose this as the long continuous carbon chain, then we have 2 methyl groups, one is at 2 position, another is at 4 position, and then 1 ethyl group. On the contrary, if we choose this as our long continuous carbon chain, then we are having only 2 substituents. Whereas here you have 3 substituents. Therefore, you have to choose a chain that has the maximum number of substituents, and therefore, this is correct. You can't name in the reverse way here, because if we do that 1, 2, 3, 4, 5, 6, then your substituents will be at 3, 4, 5 position. Whereas, if you follow the numbering that is there in the blue color, then that will be 2, 3, 4. Therefore, that is correct. So, the correct IUPAC name for this molecule is, once again follow the alphabetical order. So, 3-ethyl, that comes first. Instead of mentioning the methyl, you have to mention the ethyl group first, and then 2, 4 dimethyl, and then we have 6 carbon atoms in the parent chain, therefore hexane. 3-ethyl 2, 4 dimethyl hexane. That is the correct IUPAC name for this molecule. Let us find out the correct IUPAC name for this molecule. We have 2 halogen atoms as substituents, one is bromine, another is chlorine. So, number it left to right, 1, 2, 3, 4, 5, 6, 7. In the other case, number it right to left, 1, 2, 3, 4, 5, 6, 7. So, the substituents are at 2 and 6 position in both the cases, whether we number it left to right or right to left. And therefore, here the alphabetical order is something we need to use to decide which name is correct. Between bromine and chlorine, bromine comes first, B comes first before C, and therefore, this is the correct way of numbering for this. Therefore, the IUPAC name for this molecule is 2-bromo 6-chloroheptane, because we have 7 carbon atoms in the parent chain. Let us say I introduce a methyl group here. Is it possible for you to identify the correct IUPAC name for this molecule? Please feel free to pause the video and try to work it out yourself and then come back. So, do the numbering again. 1, 2, 3, 4, 5, 6, 7. Here the substituents are at 2, 3, 6 position, and then right to left 1, 2, 3, 4, 5, 6, 7. Here the substituents are at 2, 5, 6 position. Just like the previous example, can we decide this one as correct? No, this is not correct. This is incorrect. Why? Because the methyl group comes at 3 position, and that makes the point of difference here. Remember, alphabetical order is important, but what is more important is whether you are following rule number 2 or not. Once you decide the parent chain, in this case deciding the parent chain is not at all difficult, but once you decide the parent chain, the next rule is all about finding the substituents, where the substituents you have to give the lowest numbers possible. So, if you follow rule number 2, then this is correct. This way of numbering is correct as per the point of difference principle. So, now you name it. Once again, you have to follow the alphabetical order rule. So, 6-bromo, and then 2-chloro, 3-methyl, heptane. That is the correct IUPAC name for this molecule. Thank you for watching this video, and if you do like this video, consider subscribing it to Chem Media for more useful contents. Thank you.